Rough the caliper with an adaptive toolpath. After completing this video, you'll be able to use 3D Adaptive to clear extra stock. In Fusion 360, we want to carry on with the dataset from our previous example. At this point, we've done a 2D adaptive toolpath to remove the material outside of the top hat area from operation 1. Then we did a facing operation to take it down to the top of our part. But now we need to remove the extra material from this orientation. Operation 1 was able to machine the entire outside contour, however there are still some areas where we need to finish off, for example these mounting tabs and this tab where we have a locating pin for our brake pad. So we're going to do this by using a 3D adaptive toolpath again. Under the 3D dropdown, we'll select Adaptive Clearing and we'll be using tool number 7. Once again, we want to make sure we get this from our documents because we've already used tool number 7. Select the tool and then move on to our geometry. At this point, if we use the default stock contour, it's going to be looking for material in that entire area. However, we've already used a 2D adaptive to clear the outside silhouette. So for this, we're going to try to use the silhouette option. We're going to select the outer loops and we're going to say OK. Next, we're going to move on to the heights and make sure that we're using the bottom height based on a selection. We're going to select the soft jaw and add an additional 50 thou or 0.05. Taking a look at this from a front or side, make sure that we are up above the soft jaw. In the passes section, we want to take a look at the options that we have to remove material. Right now, the maximum roughing step down is set to 1 inch, which is going to be a little bit too much. We're going to change this to a 1/2 inch, which will automatically reduce the fine step down. The optimal load is set at 0.05, which again is likely lower than this tool can handle, but we're going to use that as a conservative number. We do want to make some other adjustments to several other areas. For example, the fine step down, even though it comes in at a default 0.05, we're going to reset that to 0.025. A lot of the values inside of our toolpath dialogues are going to be linked to other values. Oftentimes when you hold a cursor over a dialog, it'll tell you information about what you see there. However, if we hold down the Shift key and hover over that same dialog, we'll be able to get information about where the cam expression is coming from. For example, if we take a look at the minimum cutting radius and we hold down the Shift key before we move over to that dialog, we'll be able to see that this is based on the tool diameter times 0.1. This gives us a value of 0.05 because we're using a 1/2 inch diameter tool. We can modify these by right-clicking and changing our cam expression values in some cases. However, we're not going to be getting into that in this course. We do also want to take a look at things like flat area detection to make sure that's toggled on, and make sure that we do have stock to leave turned on, and we're going to increase this to 0.03 in both the radial and axial directions. The main reason we're doing that is because we're going to finish off the sharp corners with the bullnose mill, which will leave a 0.03 radius in those corners. While this wasn't specifically called out on the drawing or on the 3D model, it can be used in order to round off some of the sharp corners on our design by using a bullnose mill for the finishing operations. We're going to be taking a look at the linking parameters after we've already created this toolpath. So let's go ahead and generate the toolpath and take a look at the preview. One thing that we're going to notice is it is moving into various areas. In this case, it's working around the top and then it's working down at this smaller section. And if we rotate around, the same is happening on the back side. One thing that we notice, however, is there's a lot of yellow movements where we're coming well above the part and moving over. These are rapid movements and we want to reduce these rapid movements to limit the amount of time we're spending not cutting the part. Let's take a quick look by right-clicking on this adaptive toolpath, and we want to see what the machining time is. Right now we can see the feed distance is 165 inches. That's not going to be changing, but our rapid distance is 149 inches. The total rapid time is very low at 0.07, but we could also change that by adjusting our rapids. In a small part like this, it's likely not going to make a big difference in the overall programming time, but once you start programming larger parts and the tool has to move quite a big distance, we start to see a big effect in the rapid movements adding to the overall time. A couple things that we can do going back into the toolpath is we can start by adjusting our heights. Remember that the various heights are going to determine where the tool starts and also where it retracts to. For example, if we bring down this top height plane and we bring down this plane, this will prevent the rapid movements from going so high above the part. This will save us a little bit of time. Another thing that we can do is we can go back into the toolpath and go to our linking parameters. Instead of using a full retraction policy, we can use a minimum retraction policy. We can also have a larger stay down distance, for example 4 inches, which means that it'll try to keep the tool down and prevent it from rapiding up over the part whenever possible. This is going to allow us to reduce the overall rapid time away from the part, as well as the chance that it has for moving side to side on the part when it really doesn't need to. So playing around with a couple of these settings has reduced the overall time we're going to spend doing our rapid movements. This could give us the opportunity to reduce the time machining the part, but however, if we look in the bottom right-hand corner, you can see that we've actually gone the other direction. This is now machining in 2 minutes and 12 seconds when the previous setup was 2 minutes and 9 seconds. So in some cases, depending on the size of the part and your geometry, you might find that a few of these options may increase the time slightly, as opposed to allowing it to rapid up and over the part instead of trying to work around and reorganize the toolpath. Let's go ahead and navigate back to our saved view. Make sure that we do save this before moving on to the next step.